All right, here we go, continuing our work through the Section 1 exam review. I'm going to go through Chapter 3, which is questions 20 through 21. Well, it's only two questions, but there's a lot there. And actually, at the outset, I want to go back to this one for those of you that are following along with my videos, because I realized I don't know if I actually really answered the question the way it was meant to be, to draw out the empirical rule. I think what I did well was this is good. I labeled my x-axis, but I think to be a little bit more precise, I want to go back and get these percentages on there a little bit better. So the 68 comes from one z-score up or down. So like this part right here is 68%. Then the 95 means that, so plus or minus 1 z-score is 68%. Plus or minus 2 is 95. Plus or minus 3 is 99.7. So let's do another color. So from here to here, this is 2 z-scores, right? It's plus 2 or minus 2. So this section is also 13.5. If you were to add up this, and this, you're going to get 95%. Okay, so in other words, 95% of the scores are within 2 lines of the middle. And then the last one is 99.7. So this number is the same as this section right here. So this is 2.35. Oh, come back, calculator. There we go. If you need to see this to believe this, if you add up this, and this, you're going to get 99.7. So, meaning if you go from here to here, that's 3 standard deviations down or up. 99.7% of the data will be inside that range. So, I just wanted to kind of clean that up a little bit. All right, moving on to chapter 3. This is the scatter plot chapter. There is a lot of calculator work to do this chapter. Oh, I want that to fit a little bit better. Well, okay. This is Ziggy's Ice Cream Store. And what I've already done in my calculator is I've already put the data in there right here. So just carefully do that right now and then resume the video when you're ready to keep going. So part A says create a scatter plot. Once the data is in there, you go to second stat plot. You go into the first menu, you turn it on, and scatter plot is already selected. Just make sure you have the right lists here and here. When you're ready to graph it, you hit zoom 9. And all I'm looking for here, guys, is some basic information. So temperature is across the bottom, and customers are along this side. I just want a basic sketch, so I'm going to kind of do my best to, there you go, sort of. Maybe I can scooch these up a little bit. Scooch is a technical math term, so there's my sketch, okay? So as it looks to me right away, just basic observations, as the temperature goes up, the number of customers goes up, okay? Find the correlation, all right? So you go to your stat menu, you go over to calculate, you go down to number 4. You hit enter, make sure you have the right lists like I do, and hit calculate. R is the correlation coefficient, right? That's R. So R is 0.90. That's quite strong. So describe it. So in a full sentence, I would say there is a strong positive and linear relationship between what and what, folks? That's what this is. Between BW, between what? Between, I didn't leave you much room here, did I? Between the daily temperature, daily temp, and the number of customers. It's an ice cream store, right? When it's hot out, people want ice cream. Makes sense. Find the line of regression. Well, I can draw it. That'll be fun. There it is. But if I want the actual equation, I go back to my calculator, and it was on that screen that I just had up. It's still there. See A and B right there? A is my slope. So 11.6, and then x minus 420.55. If you want to put a little context to it, it would be customers is my y value equals 11.6 times the temperature minus 420, which is why I really like to have these labels. It helps me know what x is and what y is. Okay. If we change the temperature from degrees Fahrenheit to Celsius, what would happen to the correlation value? So if these were all of a sudden Celsius, is that going to change this relationship? I guess here's a way to think about it. Europe uses Celsius for their temperature. We use Fahrenheit. Do you think ice cream sales are different in Europe than they are here? Like, no, that doesn't make the relationship is not going to change based on the units that we're using for the temperature. Um, so what would happen to the correlation is really saying what would happen to this right here. It's not going to change, okay? R will stay the same. Okay, it will stay the same. What does the slope mean in context? Ooh, good question, Feig. Oh, yeah. So the slope is 11.6. Okay. Slope is y over x. So y is, let me back up. Well, no, that's fine. It's y over x. And I like to take and put my 11.6 over 1. But what is my y variable? And what is my x variable? Rise over run, y over x. So my y variable is customers, and my x variable is temperature in Fahrenheit. And so, put this into a sentence. If the temperature goes up by 1, the number of customers goes up by 11.6. And that's how you say it. On average, if the temperature increases by 1 degree Fahrenheit, 1 degree F, the number of customers will increase by 11.6. There you go. Explain r squared. That's called the coefficient of determination. It was actually just given to you on that calculator menu, right? Right. Oh, come back. There it is. It is just r squared, 0.90 squared would be 0.81. So we know what it is. It's 0.81. And I like to add, say 81% of y can be explained by x is the generic sentence frame. But you need to put that in context. So what is y and what is x? Right? And this is why, again, I keep coming back to this. Y is your number of customers. X is your degrees in Fahrenheit. So 81% of the number of customers that's Y, right? This here, what I'm underlining, let's see, what I'm underlining here in purple, that's Y. But you have to put, don't say Y, give me the context, can be explained by the temperature that day, the temp that day in Fahrenheit, in degrees Fahrenheit. So this here, the temperature that day in degrees Fahrenheit, that's your X variable. This phrase here can be explained by, you might hear it said as can be determined by, something like that. All right, find the residual for the day. It was 63 degrees. A residual is the observed value that day minus the predicted value of that day. So 63 degrees is the observed value. Oops, I'm just kidding. That's the temperature that day. Okay, we need to find the, let me find, where's this in the table? For the day, it was 63 degrees. Here's 63 degrees, right there. On that day, we had 355 customers. So 355 is my observed, right? That's how many people actually came. How do I get my predicted value? I have to use my equation, and I have to plug in 63 for the temperature. Okay, so my predicted value, I have to find this first, is, shrink me, is 11.6 times the temperature that day minus 420.55. Okay. I've done that ahead of time here. You can do that on your calculator if you want. That's 42.86. Nope. Wait, just kidding. Boop, boop. I did do it ahead of time, but that's not what it is. Nope, I didn't do it ahead of time. Calculator to the rescue. 11.6 times 63 minus 420.55. So I got 310. Oops. Isn't it? Well, yeah, that's fine. So 310.25. So that is what the predicted number of customers was. So that goes here. Because what am I doing again? The number of customers I observed was 355. That's how many actually came that day. I predicted that 310 would come. So more customers came than I was expecting. So I'm going to have a positive residual. In fact, about 44 or 45 more customers came than I was expecting. That's what a residual is. If you made your scatter plot, that means that this data point would be above the line. All right. H, find and write the residuals for all the data, okay, and then graph them. We're going to do this all in the calculator, okay? We already have list 1 and list 2 are good to go. List 3, we want to make this our predicted values. And list 4 will be the residuals. In list 3, we're going to type in the equation. So we're going to do 11.6 times L1 minus 420.55. I'll do this on the calculator in just a second. This is my line of regression. We're going to do L1 because L1 is my X and L2 is my Y. Then list 4 is my residual, which is observed minus predicted. Okay. The Y values are my observed values. So it's going to be L2 minus L3, right? Observed minus predicted. L2 minus L3. That's a terrible L. Man, one of these days I'll get better at this. Okay, so let's just do that on the calculator. Boop. So stat, there's my numbers. So list 3, I want to make this generate all of the predicted values. So let me slow down. I went up to the top on L3 and I do 11.6 times L1 minus 420.55. And immediately there's all my predicted values. My residuals will be the observed value, list 2. Whoops, I'm not in the right spot. Go up to L4. L2 minus L3. Boom. There's all my residuals. Okay? So that's going to be find and write residuals. So I just found them all. Okay? Then graphing them is really just a scatter plot. And that's crooked. And the y-axis is up there. The x-axis is sideways. The x-axis is your temperature. Your y-axis is your residuals. So the temperature is list 1. The residuals are list 4. And so that's the input I use for the scatter plot on my calculator, L1 and L4. So stat plot menu, go into there. The only thing you really need to change is to make this L4. And then hit zoom 9 and boop, there you have it. Just make this a quick little sketch. Okay, and there you have it. There's your residual plot. Is a linear model fitting? Yes, it is. Why? You are looking at your data to see if there's any noticeable pattern, and I don't see one. You would say the residual plot has no pattern. Maybe you could also say it has an equal scatter. I don't know, I just made that up, but it sounds good. All right, like if it was like a frown, or if it was a curve, or if it was a smiley face, that would mean it's not linear. But this data is fairly scattered, okay? So I think a linear model would be quite fitting. J, how is interpolation different than extrapolation? Interpolation is predicting the number of customers for temperatures, for temps within the data set. Meaning, all of my data was where? All of my data was in the 60s and 70s. So on my scatter plot, I'd have 60, 70, and 80, but it was all really contained within the 60s and the 70s, right? There's no 80-degree days. So that would be using this equation to make predictions in this region right in here. That's interpolation, predicting inside the data set. Extrapolation is the opposite. It's predicting it's predicting customers, the number of customers for temperatures, for temps outside the data set. For example, customers on a 90-degree day. Like 90 degrees is not at all, it's not within our data set. It's outside the data set. So we are making a prediction outside the data. So like 90 degrees would be way over here, and the line would keep going, and we'd have a prediction like way up here at 90. Is kind of what I'm getting at. All right, last question. If I'm looking at the age, uh, X versus number of hours worked for my stats class, so we have a brand new context here. And I found that R is 0.79, X bar, the average is 17, and the standard deviation of X, and all this stuff. Ooh, then please compute the line of regression. This is when you need to use your green packets, unless you have these things memorized. And on the front page, there are three equations. One, it looks like this. And the second one looks like this. Y bar equals A plus B X bar. And the third one is put it all together. So this is a FRQ type question when you have to use this information they gave you to find the line of a regression. This, whenever you read this, guys, this just means find the equation, okay? So I need to find the slope and the y-intercept. And it's a little annoying, the code switching that happens here. B is the slope, and A is the y-intercept in this case. And these are on the front of your green packet. So B, the slope is B, will be R, which they gave us right here, 0.79, times dividing the standard deviations, which they gave you here. That's SDY is standard deviation of Y. So 4.3 and standard deviation of X. Okay, 1.6. Calculator time. Well, here I already have that. So you can just multiply that out on your calculator. That's 2.12. That's my slope. Then I'm going to take my 212 and put it here. And I'm going to plug in the X bar and the Y bar, the average X and the average Y, which they gave me Y bar and they gave me X bar. And I'm going to plug that in so that I can find the y-intercept. Here we go. Y bar was 23. A, I don't know. That's what I'm solving for. The slope I just found to be 2.12. And X bar is 17.4. So X bar 17.4. Okay. And B is the slope. So that's where I got that. So then I got 23 equals A plus what? Well, let's just get that number. What is 2.12 times 17.4? 36.888. Then just subtract that over to the other side, and you will have your y-intercept. 23 minus that answer, boop, negative 13.888 equals A. And again, A is my y-intercept. So put it all together to make my final equation. I have my slope and I have my y-intercept. Y equals 2.12x minus 13.888. If you want to keep it in context, they gave you y and x. So ours worked. You can kind of put this little pyramid over it to signify it's your variable. Equals 2.12 times your age minus 13.888. All right, folks, that takes care of chapter